Here, you want to build a fence for a rectangular dog run. You want the run to be at least 10 feet wide. Now, what do we know? We know it's a rectangle. Okay? Now, first of all, you need to define your variables. Like, let's say this is x and this is y. So you're gonna let length be x, or let x be the length, and let y be the width. Okay? First of all, they said that it will be at least 10 feet wide. Now the width is y. It will be at least. At least means more than or equal. So this is going to be y greater than or equal to 10. This is going to be your first inequality. The second inequality says the run can be at most 50 feet long. So the length, which is x, at most means less than or equal 50. If you notice, like you say at most, then you end up writing less than, which is the opposite. You say here at least, then you end up writing greater than. In both cases, you're going to write equal. So whenever you see at least or at most, you are going to include an equal sign. Also, no more than or no less than, you're going to be including an equal sign when you write the inequality. Now you have 126 feet of fencing. Now the fence is usually what goes around the shape, right? So we're talking about the perimeter here. So I should write that 2x plus 2y, which is the perimeter. I have two lengths and two widths. And it has a relation with 126. Now you only have 126, which means you can only use 126 feet of lengthening of fencing or less. So this is why we write less than or equal, because you only have 126. You can't do more than 126. So this is a third inequality. Now we are supposed to use all those three inequalities to make a graph that will give you the possible dimensions of this. Now, how do we make the graph? Now, we have already decided now that this x here will represent the length and that the y-axis here will represent the width. Now, take in consideration that every time you're solving our problem, most probably you'll be only using one quadrant, the positive quadrant of the coordinate plane, because all values, length and width, are only going to be positive, never negative. Now, let's graph the first inequality. We have y greater than or equal to 10. When we represent this by a line, we know that this is a horizontal line. Y greater than or equal to 10. When I want to represent that line, it means that no matter what, the value of y is 10, regardless what the value of x is. So let's graph the line and see which region above it will be or under it will be shaded. Now at y equal 10, now here we skip counting by 5 for each square. So this is going to be my line. Okay, now I said y is greater than or equal to 10, which means all the values above that, not below it. So this made some kind of restriction. All the values I need for y are going to be above this line, but not below it. I have another inequality, x less than or equal to 50. Now x equal to something is a vertical line. It means no matter what, the values of x are going to be always 50. So if I want to graph this line, let's choose another color. It's going to be at 50 here. I have 40 and I'm skip counting by 5. So this is 50. Now, I said the value of x are less than or equal to 50, so I am restricted with this side of the line. So I'm going to be working above the red line and to the left of the green line. Now, my last line that I need to graph here is the one that has represented by the inequality 2x plus 2y is less than or equal to 126. In this case, I'm going to use the slope, the x-intercept and the y-intercept to be able to graph the line, because it will not be easy to find a slope on if I'm skip counting by 50. Now, how do you find the x-intercept? Now, the x-intercept is the point on the x-axis. The values on the x-axis of y is equal to 0. So to find the x-intercept, you are going to actually substitute for y equals 0. Again, x-intercept is a point on the x-axis. All points on the x-axis have a value of y equals 0. This is why we are going to substitute for y equals to 0. Then you're going to have 2x is less than or equal to 126. Divide both sides by 2. Then you'll get that x is 63. So the point is going to be 63 and 0. So here at 63, well, I'm skip counting by 5, so it's somewhere here. And 0, this is your x-intercept. The y-intercept is where x is equal to 0. We know that. It's on the y-axis. So you're going to be solving the same thing again. So I have 2 multiplied by 0 plus 2y less than or equal to 126. Again, divide both sides by 2. You'll get that y is 63 again. The point here is going to be 0 and 63. So at 0 and 63, which is somewhere here, this is your second point. I am going to actually connect this line. So to find possible answers, what are we going to do? We are going to write all possible inequalities and graph them. Okay? We said that the region will be, because I had x less than or equal to 50 on this side of the green line, right? It's also going to be above the red line, so here. Now, what is the relation with the blue line? It says here that 2x plus 2y is less than or equal to 126. When I see this, all I'll be thinking about is shading below the line, because I have less than or equal, but it's safer to check. So I'm going to check using any point. Let's use 2020. If I use the point 2020, then 2 times 20 plus 2 times 20 should be less than or equal to, sorry, no space, 126. Well, 40 and 40, which is 80, is that less than or equal 126? Then yes. So I can actually shade the region here. Now, which is the intersection between all three of them? I don't want to do 3 shadings. It's going to show like it's going to look terrible. But the intersection between all of them, to the left of the green line, above the red line, and below the blue line, is this region. Now, this region here shows you all possible dimensions that you could get for your dog run. Okay, so any point in that region is a solution. Like if you choose a point here, let's say this one. This is 20 and 25. You can make your dog run. 20 here represents the x is the length, has a length of 20 feet and a width of 25 feet. You can make it with a length like this point here, where I have 10 and 40. I can make it 10 feet long and 40 feet wide, and so on. Any point in this shaded region is a possible dimension for this dog run. Now, we have discussed systems of inequalities, how to graph them, how to find them from a graph, and types of word problems that are related to this. This type of word problem is called linear programming. Now, I hope this has been helpful for you. This video depends on a lot of information that we discussed in previous videos, like linear equations and systems of equations. You can look back at them if you need more information, and thank you so much for watching.